Welcome back, ladies and gentlemen. Today you're going to learn how to graph a quadratic equation. We've been working an awful lot in the past 2 weeks with being able to solve a quadratic equation, but this time we're going to start thinking about things a little bit more visually. So we're going to shift away from solving these equations slightly. We're not going to get rid of that idea, but we're going to get away from solving them to how to graph them. And we're going to start from the simplest cases and work a little bit more towards a complex equation. And we're going to learn multiple techniques on how to do that. Now, sitting in front of me is a quadratic equation, and it's the general form, and it's showing the most complexity that it can. It's showing all three terms. We've got an ax squared term plus a bx term plus a c term. And you'll notice that I've highlighted the coefficients in a different color. That's because just like your y equals mx plus b equation, where you can make any line using a different slope and a different intercept, or a different m and a different b, you can make any parabola, that is this shape, is kind of U-shaped, by changing the coefficients in front of each one of these terms. By changing those, you can make any sort of parabolic shape that you wish. Now, like I said, we're going to start with the most simple case, which means that for today, we are going to get rid of that middle term. And we are going to simply deal with the formula y equals ax squared plus c. The purpose of this video will be to get you to a point where you should be able to graph a parabola by using a table. Then what we're going to do in class is we're going to figure out what effect A and what effect C has on the overall shape of the graph. So I want to get you able to graph a parabola by using a table with using this video, and then tomorrow in class we will try to establish some patterns of what A and C do to the shape of the graph. Okay, first a little review of vocabulary. Earlier in the trimester one, we talked about domain and range. Domain, if you remember, was the set of input values for a function, that is the complete set of all the x values that could possibly go into the function. And range was the set of output values for a function, or all the possible y values that you could get out of a function. Now, when we were graphing linear equations, we learned many ways to do it, but one of them was by table. And what we did was we chose a domain. We simply chose random numbers. It kind of looks like there's a pattern in this very short table, but we chose a random set of domain numbers. We then plugged them into the function. The function was written in function form, where we had a y all by itself, and then we had x along with all the leftovers over on one side of the equation. We plugged in our x, so in this case we take -2 times -4 and then add 7 to it. So we did a little bit of work to it. And then we got our answer of 15. We continued on down to the table until our table was complete. After we did that, we graphed these coordinates, -2, 15, 0, 7, and 2, -1. Now, for our quadratic equations, we're going to do exactly the same thing. So up in the upper part of your screen right now, you'll see a very simple two-step process that we're going to follow in order to graph any parabola by using a table. Step number one is just says choose at least 5 input values. And it has a little hint under there that I'll get to in a moment. But it says choose at least 5 input values. And you remember when you're graphing a line, I told you that 3 was sufficient. 3 was sufficient because once you had the pattern of a line, you could continue that line fairly easily. Well, now we're trying to make a pretty complex shape. We're trying to make a parabola, one of these curves. So we have to be a little bit more accurate about where our points are. In order to see the shape of that curve, we need 5 points. 7 is better, and you'll see that my table sitting in front of me here actually has 7 slots in it. So I'm going to use 7 input values and work from there. Now you also see a little blue note under there that says -2 to +2 often works well as a domain. And I would say for about 70, 80, maybe even 90% of the problems that you're going to experience in this chapter, that's going to be true. That domain won't always work. And remember, you can choose any domain that you want, but -2 to +2 will usually get you in the ballpark or at least establish a pattern so that you know which domain to choose. So like I said, my table has 7 different places in it. So I'm going to choose a domain of -3 to +3. And I'm going to use those values to substitute into my equation for x and calculate my y. Now, in order to do that, my substitution would look like this. And we just have to remember our order of operations to say exactly what that means. What this means, order of operations says parentheses first. Okay, so think of it as a -3, then exponents. So I'm going to take -3 squared. That is -3 times itself. So -3 times a -3 is a +9. Then we move on to multiplication. So we got a +9 times 2, which would be 18, and then subtract 8. Okay, and we will get an answer of 10. Now, not everyone likes to do that in their head, and I would encourage you to do it in your head because you actually probably make fewer mistakes than if you were to enter it into a calculator, and this is why. This right here in the green rectangle is the correct way to enter that into your calculator. Now, if you had forgotten this set of parentheses, what your calculator would do is it would take the exponent first, and it would take not -3, but +3 squared. So you get 3 times 3, which would be 9. And then this little negative sign or that opposite symbol says take the opposite value of 9. So this -3 squared right here in your calculator would actually be evaluated as a -9. And you need that to be a +9. So you need to surround all of your inputs in your calculator with a set of parentheses, especially if they have exponents on the outside of it. Otherwise, your calculator will not take into account that you've inputted a negative value. Okay. Proof of that, or for further proof, you can calculate the +3 case right here, which you should get the same value. 3 times 3 is 9, times 2 is 18, minus 8 is 10. Okay. So go through the table, fill it out. See if you can pause the video and fill out that table completely. If you do so, you will get these values for your y value. So the only thing that I've changed down my table is what input value I used for x. -2 times -2 is 4, times 2 is 8, minus 8 goes back down to 0. Okay, and so on. You fill out the entire table, you get some coordinates. Okay, we have -3, 10. So now that I have coordinates, I can go ahead and plot them on this graph, and this is going to look a little bit different than anything you've done in a while. I want that one. All right. Then, so this says -3, 10, so I go left 3, up 10, make a dot. Next one is -2, 0, then -1, 6, or sorry, -1, -6, then 0, -8. And then you'll notice that it is actually symmetric, and we're going to exploit that in 2 chapters. But for now, that's what the shape of the curve looks like. So it's kind of a bell-shaped shaping up, facing upwards. We call that a parabola. And if you connect the dots, you want to do so smoothly. You do not want it to be a jagged V point. You want to try to do a nice, smooth curve all the way through. And I stand absolutely no chance of doing that by hand with a computer mouse. So I've prepared myself and graphed a nice one using some graphing software. So again, notice that it's a nice curve. This does take some practice. A nice curved shape to it. This does not come to a point. Do not draw pointy parabolas. It annoys me greatly. And that's what it looks like, roughly sketched on the same viewing area as we had before. The next example that I have is just one notch tougher. I have a -x squared sitting there. To deal with that -x squared, especially in your calculator, you need to remember that there's going to be an additional opposite or negative sign sitting there. So when you're typing that into your calculator, it'd be opposite symbol, parenthesis, opposite symbol, 3, close parenthesis, exponent, plus 9, okay? If you're evaluating this in your head, you do it the same way. Negative 3 times negative 3 is positive 9. Then take the opposite value of positive 9, which would be negative 9, and then take negative 9 plus 9. So your answer ends up being 0. Okay? See if you can fill out the rest of the table. Pause the video, try to fill it out, and come back. If you do that correctly, you will again get a symmetric pattern. It goes 0, 5, 8, 9, 8, 5, 0. And then you can start plotting those points again, just like we did before. So I have negative 3, 0. I have negative 2, 5. Negative 1, 8. 0, 9. And then it's symmetric. So you can see that these things are a mirror image of each other on either side. And again, you want to do your best towards connecting the dots with a nice curved line. Again, I use some graphing software to assist me. That's how you graph a parabola by using a table. I will see you tomorrow, and we will get to work on trying to figure out what these numbers in front of the x squared and what the constant term does to the shape of the graph. I'll see you tomorrow.